Tesla has always been a company that pushes the envelope, and their latest development is no exception. The Plaid motor is a new type of electric motor that is more efficient and powerful than anything else on the market. Here's why Tesla developed a Plaid motor and what it means for the future of electric vehicles. So let's get started. Hey intellectuals, welcome back to the Future Space. Today's video is gonna be really informative, so make sure to watch the video till the end because we are going to reveal some secret and sensitive information. But before we begin, make sure you subscribe to our channel and click the bell icon so you don't miss any of our amazing videos, and let's begin. The major role of Nikola Tesla. Okay, we all know Tesla the firm is named after Nikola Tesla the man, right? Nikola was an inventor and engineer who worked with electricity and magnetism in the late 1800s and early 1900s. He invented the radio, the remote control, and the Tesla coil, which bears his name. But Nikola invented the induction motor, an alternating current motor powered by electromagnetic induction, which is why Tesla the car firm bears his name. Again, that sounds complicated, and it is, but we can make it simpler. It all begins with magnets. So here's a short and simple experiment that we can all relate to. If you have a compass, you know that the needle always points north. The magnetized needle will always be aligned with the Earth's magnetic field, and the north pole of the magnet will always attract the north pole of the Earth. If you put a magnet near your compass, the needle will spin to align with it, since it is now the strongest force of attraction. If we transfer the magnet to the opposite side of the compass, the needle will spin to that side and follow the magnetic field. The needle will continue to spin as you move the magnet around the compass, so we just used a magnet to create rotation. That's awesome. On the other hand, we know that magnets may provide a strong push or the polar opposite of attraction. We've all tried pressing two magnets together, only to discover that there is an enormous force preventing us from doing so. An electric motor simply uses the force of push and pull to spin the rotor, but you can't have a consistent spin without bringing in electromagnets. That's when things start to become weird. So a substance like copper is incredibly conductive, but it is not magnetic. That is, unless we pass an electric current through it, at which time it becomes an electromagnet. So this is a non-permanent magnet. If the energy is removed, the magnetism is also removed. This allows us to exert remarkable control over the magnetic field. A permanent magnet, like the one on your fridge, is so named because it has a physical north and south pole that can't be adjusted. You have to physically move the magnet to rotate the magnetic field. The magnetic field of an electromagnet, on the other hand, will follow the direction that the electrons are traveling through the conducting material. Therefore, reversing the flow of energy will reverse the poles of the magnet. Electromagnets can therefore swing both ways depending on the type of energy applied to them. To reverse the poles, you no longer need to physically turn the magnet. Before we move further, have you subscribed yet? If not, then you're missing some important information, so make sure to subscribe to our channel. Now it's time to look inside the electric motor, so make sure to pay close attention. So now we can look inside our induction motor, which has two major components, the stator and the rotor. The stator is the motor's outer ring, and the rotor is the inner center that spins. The stator is motionless, the rotor is turning. In this application, our rotor is an iron core surrounded by rows of permanent magnets that run lengthwise. For the sake of simplicity, let's say there are 4 rows, and these magnets are evenly spaced around the ring, top, bottom, left, and right, and each quarter of the ring has an alternating pole, so they go north-south as you go around. The stator is a tube of electromagnets composed of several coils of copper wire that surround the entire ring and run lengthwise. Each coil of wire is a separate electromagnet that can be turned on and off, and its polarity flipped simply by controlling the flow of energy into each coil. By putting the rotor inside the stator, we create a magnet within a magnet. When you bring two magnets close together, there will be a natural push and pull, with the opposite poles pulling towards each other and the like poles pushing away. However, once the first alignment is achieved, the rotation will come to a halt. To keep the rotation going, we simply shift the north and south poles of the stator magnets around the outer ring. Again, we accomplish this by regulating the direction in which electrons travel through the wire coil. Moving the south pole of the stator around in a circle will draw the north pole of the rotor along with it, and conversely, moving the south pole of the stator around in a circle will push the south pole of the rotor. The rotor will spin due to the constant force of push and pull, and the faster you change the magnetic field around the stator, the faster the rotor will spin. When we see the Tesla T logo, we're looking at a cross-section of an electric motor, with the top curving line representing the stator ring and the sharp T shape representing a slice of the rotor. Hopefully that made sense and was at least mostly correct. We are not saying this is a textbook-worthy explanation, but it should be sufficient to convey the primary notion. Now it's time to look inside Tesla's Plaid electric motor. Now that we've cleared everything out, let's get into what makes the Tesla Plaid electric motor so unique. There's more to making this automobile fast than just having 3 motors instead of 2. If it were that simple, everyone would do it. It would also mean that the Rivian R1 with 4 motors would be the fastest vehicle in the world, which it isn't. We know that the Plaid design is distinguished by the use of a carbon sleeve on the rotor, as described on Tesla's product page. Elon discussed a lot about this carbon sleeve technology during the Plaid launch ceremony at Tesla HQ in 2021. Normally, a rotor would have a steel sleeve around the outside, but this is the first one Elon is aware of that uses carbon composite. So what we have here is an extremely tight wrapping of carbon fiber threads around the exterior of the rotor. Imagine the rotor as a bobbin spooled up with thread, or even a fishing reel if that's more familiar to you. The carbon fiber thread is then immersed in epoxy until it solidifies into a solid mass. Elon claims that Tesla performs this wrapping process under extreme tension. They actually had to build a new machine capable of wrapping the threads tight enough, and that they do so because the rotor material shrinks in low temperatures, but the carbon fiber does not, so the carbon has to compress the rotor to prevent a separation from occurring when the rotor contracts. So, what's the point of bothering? Just as the rotor can contract, it can also expand, not only at high temperatures but also at high forces, such as when the rotor is spinning at 20,000 RPM. The centrifugal force on the rotor would push it to extend outwards, and Elon implied that it would even fly apart if not held together by the wrap. Alright, before we wrap up and recommend you to watch this video, if you really want to know about the impressive yet dangerous engineering of TeslaBot. And that's it for today, guys. We sincerely hope you enjoyed the video. If so, please click on the like button and share it with your friends and family. If you have any questions or comments, please share them with us in the comment space below. Also, don't forget to subscribe to our YouTube channel to see even more of our incredible videos. Thank you so much for watching, and we'll see you in the next one.